Hey, what's going on, folks? It's Mike here, and welcome to our OpenGL series. In this lesson, we're going to start off by setting up our OpenGL application. Now, in this lesson, I'm going to be using a framework called SDL2, and I'm going to be demonstrating on a Linux machine how to do this. But don't worry, I have a bunch of playlists on how to get set up with an OpenGL application on many different platforms, and I can also add those into this series at some future point. But for now, I want to go ahead and get us started. So, in order to get us started, let's go ahead and look at the SDL framework here. So I've gone ahead and pulled up the page here for the Simple Direct Media Layer. Now, what is Simple Direct Media Layer? Well, it's a platform that will work on Windows, Linux, Mac, even gaming consoles. So it's one that I like to use because professionals use it, as demonstrated by these games you can see here. So in order to get set up with SDL, I'm going to defer you to some of those videos on the setup later on in the SDL series playlist that I have, so you can go ahead and check out that. So once you are set up with those, though, let's go ahead and talk about the role that SDL2 plays. So in looking at SDL2, here we've got this framework here that does various input-output events here. So here's SDL2, which is one of our dependencies that we're going to have here. And the basic idea, or what we're going to use it for primarily, is to render a window. Okay. And the goal of this window is going to be able to hold or display the output from an OpenGL context. And what an OpenGL context is basically the large object that holds onto OpenGL, this sort of graphics library that we're learning about, and is going to be communicating between our GPU and our CPU. If you'd like to take a few moments to get an understanding of the OpenGL context, well, this is basically what it is. It's a context that stores all the associated state with OpenGL. So you can think of it as one big object, if you're used to object-oriented programming, that basically holds everything. The important part of it is this thing called a frame buffer that holds a lot of the rendering commands and can display the information ultimately to our SDL window that we have here. SDL is also going to be responsible for doing some other things for us, such as handling input and output. So I'll just abbreviate that as I/O, and even setting up other subsystems, such as sound, or even networking, and images, and SDL as well provides additional functionality such as threading support and general compatibility layers for working with different operating systems, as previously stated. But again, the primary use for us for having SDL is for launching this window here. Now, how do we build a graphics application? Well, typically there's a few stages that we want. So we need to initialize our scene here, which is usually the first part. And then most of our graphics applications are going to have some sort of main loop in which we'll handle input. Again, that'll be the I/O portion here from SDL. Maybe do some updates based off that input, and then eventually render. And render itself can be broken up into perhaps multiple stages, such as a pre-render or a pre-draw. That would take place, again, before rendering and might be responsible for setting up some state, for instance. And then finally, we need to have a cleanup function, which removes all of the stuff that has been initialized, such as SDL, any memory that we've allocated, and so on. So let's work with this to go ahead and start setting up from scratch our SDL application. So what I'm going to go ahead and do is start a blank project. I'll keep our outline here so we can keep this in mind, but let's go ahead and start coding together our first SDL application. We'll get OpenGL set up, but we won't be rendering anything quite yet. We're not quite ready for that, and I want to take some time to explain the OpenGL things, but this will be the first stage in our process. So the first thing I'm going to do, again, is just open up an empty file here, and I'm going to go ahead and include SDL2 and the SDL header. That gives us all the SDL functions and makes them available for us. And let's just go ahead and have a main here. And this is our entry point into the program. Now, as I mentioned, I roughly want to break out this program into a few stages here, where I'm going to initialize things, have a main loop, and then clean things up. And usually a nice way to do that is to break things into functions. And it's a nice way to start breaking our program into these modular pieces that could either be swapped or otherwise just organize our program. So I'm going to go ahead and just call this initialize program. We'll have a method for that. And let's just call it main loop and something called the cleanup function. So I'll have these three functions here, which I need to declare and define and set up here. Now, one caveat with the code that I'm going to be writing right now. One, I'll go ahead and say that it's probably not going to be perfect. We'll have to fix some errors, but we're going to do things as simple as possible and leave it a little bit up to you to add some abstraction if you'd like. Maybe in later lessons we can add some abstraction together, but for now, we want to just be able to understand things. Okay, so let's go ahead and create these different functions here, and I'll leave this as such. Now, anytime I write any amount of code, I like to compile relatively frequently. So how am I going to compile this? G++, the file, the output here. Let's go ahead and see what happens, and it compiles fine. Now, we are going to eventually get some errors when we link in SDL2, but we are going to need to do something like link SDL2 here. And on Linux, I need to link in this dynamic linking library so I can load libraries at runtime. So let's go ahead and see if that works. Seems to take care of the problem and we'll be in good shape going forward. Okay, now let's go ahead and start off with this initialize program here. And in order to do this, the first thing that we're going to need to do is just initialize SDL. So I'm going to do something like if SDL init, and the subsystem that we need to initialize is the video subsystem. If this value returns less than 0, then it's an error. So I'm just going to exit. And it's usually nice to print off some sort of message here. I'm going to use cout. You could use cerr to retrieve the message, or even SDL log if you want. But I'll go ahead and just say SDL2 could not initialize video subsystem. Now note that it might also take some shortcuts here as far as handling every condition for possible errors and error detection. Again, just to make this code simple. Okay, so let's assume that we're able to initialize SDL here. There's also going to be, when we initialize something, some sort of cleanup function that we would also want to take care of here. So let's go ahead and look at our cleanup function. And what we're going to need to do is equivalently call SDL quit. Okay, so let's just go ahead and start with that much. I'll go ahead and compile now. And now that we're actually using some SDL commands, we'll see if it's properly linking here. Now I am missing the IO stream library. Let's go ahead and put that in. And then I'll recompile, see if I get any errors. Nothing. And if I run my program, it doesn't do much of anything. So our next stage is actually going to be to create a window here. Now, again, this is where I'm going to take some shortcuts and just create some global variables for us. And let's just label them globals and start setting up our window and our OpenGL context. So let's just create an integer here. I like to prefix my variables with lowercase g if they're global, if I must use them. And we're going to create some things for our window here, such as the width and the height. We'll need an SDL window, and that's a pointer to one. And I'm just going to call this the graphics application window, and we'll set it to null pointer. And we are going to need a OpenGL context. And I'll just prefix that again with a G, OpenGL context. And this is going to also be a null pointer for the object. Okay, so let's go ahead and just tidy things up just a tiny bit here. And let's go ahead and create our window. Now, before I get too far into this, let's go ahead and see what or how to create a window. Again, I happen to have some SDL experience, so some of these things I can remember, and some of them I just have notes, to be honest. So let's go ahead and look for SDL create a window. And we can go ahead and find this function here. And I'm just going to go ahead and copy this so that I don't make any mistakes. Let's leave it over here. and leave our window here, and let's create our window. Okay, so the title, let's just go ahead and make this OpenGL first program, or first window, however you'd like to name it. And make this a little bit bigger just so I can indent it a little bit easier. Oops. Here, let's try that again. OpenGL window. The X and the Y is going to be the starting position. So I'm just going to make those 0. The width is going to be our G screen width. Our height, G screen height. So I can get rid of this flag here. And the actual flags here. Okay, so what are those going to be here? And again, let me kind of tab this out just to be a little bit neater. But what are the actual flags? Well, if we look at our window here, we have to figure out what type of window that we create and what it's going to support. And this is going to be very familiar or very similar if you've used other frameworks like GLFW. But we can go ahead and see one of the flags here, SDL window OpenGL. Again, if you're going to use Vulkan or Metal, perhaps and at a later time we'll do a series on that. But this creates a window usable with an OpenGL context. And that's what we want. We want to be communicating with OpenGL graphics hardware. So let's go ahead and use SDL window OpenGL. So that's going to be SDL window OpenGL. There might be other flags that we want to use with this. There's a common one that I'll also use for SDL window shown, for instance. Let's go ahead and see if that one is here. SDL window shown. And it says it's ignored here, but you know, because it's implicitly done. So let's just go ahead and use SDL window OpenGL. Now, just out of curiosity, let's go ahead and see if this worked. And one way to do that before running it is again to see for our window here. Well, we've got to assign it here. Our G graphics application window is just to test if this was null or not. So I'll say if our G graphics application window is equal to the null pointer, then it did not set up, unfortunately. So we'll go ahead and exit and have some sort of error message. SDL window was not able to be created. And again, you can get as creative as you want with the error handling or put logs or custom object so only you see them in debug builds or whatever, and that would be fine. So let's go ahead and just start with this much. And again, we're not going to see anything yet. And that's for a few reasons. One, our program doesn't have a loop that's going to run, or an infinite loop, the application loop. So even if a window did pop up, it is already gone. And secondly, we still have to set up our OpenGL graphics context. So let's go ahead and do that. And again, that is this G OpenGL context here. So let's go ahead and see how we set that up. And again, G OpenGL context. There is a function in OpenGL, SDL, GL, create context. And let's go ahead and find it in the documentation. Let's see if we can find it here in create context. Sometimes there's useful documentation down here. But let's go ahead and see the categories for video. And let's see if there's a create context here. And here it is for OpenGL. Okay, and similarly, there'd probably be context for other things, but we just need to specify the window for which we are creating the context in. And that's our graphics application window. And we'll again check if this is null. And it could be null for a variety of reasons, such as the window not being created, or perhaps the OpenGL driver is not working on your system, or perhaps other reasons. And we could use SDL getter to query some of these things if you wanted. So we'll just go say OpenGL context not available. And I'll just put an end line here. Okay, so here's what our code looks like. Let's go ahead and compile, see if we made any mistakes. And so far, so good. Now, before we get into writing the main application loop, what I actually want to do is specify some properties of our OpenGL context. And we can actually do these with something. Let's go ahead and look here again. SDL GL set attribute. And there's some different attributes that we are going to want to set here for our particular OpenGL version. So allow me to just scroll down here. You can see some of these related to the sort of double buffering, the depth buffer size, these sort of things. What I actually want to do here is set some attributes, and I'm going to even do them before I create the window, but after I initialize SDL here, and the sort of important ones. So one is going to be SDL GL context major version, and I'm going to do version 4. In fact, I'm going to set a few attributes here. The minor version that I'm going to set is version 1. And basically what I have here, this means that we're going to be using OpenGL version 4.1. And this should be available on folks who have Mac, Windows, or Linux machines. Mac, unfortunately, at this time, for the most part, doesn't support beyond version 4.1. Linux and Windows, you should be fine. If for some reason this doesn't work on your machine, you can try version 3.3 and be able to do pretty much everything in this series. But I'm going to leave it at 4.1 so we have modern features available to us. The second thing that I'm going to actually set up here for this next attribute is going to be called SDL GL context profile mask. And what I'm going to set here, and let's actually see if we can search for it. We could actually query here, but let's actually just search here, just so I can show you a little bit about how to find the SDL documentation. And of course, follow my SDL series if you want to see more of this stuff. But let's do SDL GL context. Let's see what shows up here. So you can find some of these things like the major version, minor version. These are all the GL attributes. But this is the one that I want to set here, the profile mask here, excuse me. And the GL, SDL GL context that we're going to actually set is going to be the profile core here. Okay, so we can see these attributes all listed here by searching here. Okay, so let me search for that word core here, and that is the type here. So if I see SDL GL compatibility here, and let's go ahead and just zoom in on this because this is an important thing to keep in mind with working through this series and this being a modern OpenGL series. The core profile here, as mentioned, says deprecated functions are disabled. So that means all the old functionality, even if your graphics, hardware, and driver supports it, is just not going to be available. And that's what we want to do. We want to get rid of the old stuff and force us to use the new modern stuff that's going to be supported on later hardware. So let's go ahead and grab that here. Go into our source code and set up the core profile in this manner. All right, now some other settings that I'm going to set here. Again, I won't look for all of them, but you get an idea of how to search. I'm going to turn on double buffering, which allows for smoother transition of things. We'll talk about double buffering a few times, or at least mention it, so you can search on your own. And the depth of our depth buffer will be 24 bits, so we get more precision when determining if objects are overlapping. Okay, let's go ahead and compile, see if I made any mistakes, and miraculously, none so far. All right, so with that in mind, let's go ahead and continue and see what we have here. So I'm pretty happy with this initialization function here. I think we've initialized all the things that we need. We have a window, and we have some way to communicate with OpenGL. We'll verify if that works. So our initialization in that sense is done. And we're even starting to clean up our program here. In fact, it's probably a good idea at this point to not forget to destroy our window, because that's something else that will be allocated. And for that, there's a function called SDL destroy window, and this is our G application window. Now, notice by prefixing everything with G, it makes it a little bit easier for your IntelliSense, so that's just another tip for free. All right, so that should destroy our SDL window here. Okay, now let's actually get into writing the main application loop here. And what I'm actually going to do here is create another global variable here. And again, I know it's not the best thing to do here, but I'm just going to call it a Boolean here, and I'm just going to call it quit. And I'll just say, if true, we quit. And basically the idea is for our main loop here, I'm going to have some while loop here where I'm saying while not gquit, so we've initialized this to false, then just keep running forever, forever, and forever. Okay, so that's the basic idea. Okay, and now what I'm going to actually do is have a input function. I'll have a pre-draw function, as I mentioned. I'll have a draw function, which will actually do our drawing. And then I'm going to have a function for SDL, GL, swap window. And this is going to be for our graphics application window. And this is essentially what's going to update the screen. So the way that double buffering works is when we're actually drawing a graphics scene, you can sort of imagine it like a flip book that's playing, if you've ever played with one of those toys. And basically the idea is we draw to the back, and as soon as we're finished drawing, we send that information to the front buffer, and then we start drawing something else on the back while the front is displayed to the user, and then we just keep flipping. So that's essentially what this command is doing, okay? All right, so let's just handle one of these functions at a time. First, by creating them here, I'll create input. And these are all just going to be void functions for now. We need a pre-draw. We need a draw function here. And last but not least, that's actually it. Okay. So for pre-draw and draw, we're actually not going to do anything with these because these will be related to OpenGL. Today, again, it's just about setting up and understanding our sort of graphics framework. So for handling input in SDL, what we're going to do is have some event. SDL event is a type, E. And I'm going to say while, and we're constantly basically just going to pull and see if there are any events here. So I'll pass in that event. And if there is some event to look at, we will handle it. And for now, the only event that I really want to handle is if the user exits our program. I'm just going to say if the event type is a quit event, then we'll go ahead and terminate our program. Okay, so we'll just do that's out, goodbye. And that's the idea here. And I'm not actually terminating the program here because I want to actually run through this input and then terminate out of my main loop here so that I complete this function and then go into the cleanup function. That's at least going to be our structure for this sort of sandbox application where we're learning OpenGL. Okay, so revisiting this, I just need to set my toggle equal to true. Okay. So now we're essentially handling in an infinite loop any events that happen. So if I'm holding a key down, those would be handled here. We're drawing or otherwise displaying our window, and we should actually have some window here. So let's actually try our program because we have an infinite loop here. Let's see if I made any mistakes. Looks like I made one spelling mistake here on SDL destroy window. Let's see if I just spelled something wrong, one extra underscore. I'll recompile, we'll rerun, and it popped up on my other screen, but here we have a window here. Now it looks like I flipped the dimensions in sort of a weird way. We have a very long window here. So let's actually change our dimensions here. I tend to like, at least on a desktop application, something that's 640 by 480 to test, and recompile, rerun, and just like that, we have an empty window that should be compatible with OpenGL. Now, how do we know though? I want to go one step further and actually query some of this information here. So what I'm going to go ahead and do here is let's go ahead and run some OpenGL functions here to see if our program is properly set up here. So where do I want to do that? Well, the initialization probably makes the most sense here. But I'll actually write another function here. I'm just going to call it get OpenGL version info, something like that. And we'll just have a bunch of cout statements. And some of the strings that we can query. Again, these are ones that I have in front of me. But we can search glGetString. And let's actually do it. glGetString. just so you can see the different enumerations, the things like the vendor, the renderer, the version, and the shading language version. And you can query for individual extensions, which we'll talk about. I actually want to just do these 4 here, just so you can see that OpenGL is working. And it's also useful if it's not, if you can, report back this information to, whoever's helping you debug this. Whether that's me in the comment section below, somebody that you're working with, or the World Wide Web. All right, so let's go ahead and set some of these up here. So again, these are going to be GL version and the shading language, which we will talk about here, which I believe again was just GL shading language. And let's go ahead and compile, see if we made any mistakes. Oops, looks like I made a few mistakes here. And well, that's actually somewhat intentional because, well, we don't know about OpenGL. Where is the library included? It's not an SDL, so how do we know about these functions here? In fact, let's go ahead and take a closer look at these errors and see if they gave us anything, more useful here. If I go ahead and scroll up here. And we don't even know about glGetString. Okay, so how do we figure out about glGetString? Well, in order to understand this function name, I'm going to need to download a library here. The glad OpenGL tool is one way that we can have a header that has all of the OpenGL functions provided. So I like using this tool. Some other folks will point you to glue or other tutorials. Glue is spelled GLEW, all lowercase, but I like using glad here. So let's go ahead and run through this process and get a header file that will set up OpenGL essentially, or the functions. So I'm going to use the language for C++. I'm interested in OpenGL. We said version 4.1 here. And this is all the different features that we have here. So I'm just going to add all of them. And let's go ahead and see what options we have here. Generate loader. Okay. We want to use the core profile, which only gives us the new functions. Again, we're working with OpenGL, not anything else. So let's go ahead and hit generate. And this will just take a few moments to generate a zip file for us. You could use this link here, but I'm going to go ahead and just download the zip. Let me open it up. And I'm going to go ahead and just copy this zip file here in my directory where I'm working. Let's go ahead and extract it here. And I'm just going to name this folder glad. I must have already had it here. And you're going to go ahead and see that there is some source here, and there's an include directory. And in fact, in order to build this, just to make things a little bit easier, well, I'll just go ahead and leave it. Well, let's see. Let me go ahead and I can go ahead and just move these two out here. And we'll have a source directory with our source file and the include directory with the glad header file. Now, just to take a moment to look at these tools here, or what we have here, again, here's the actual header file here. Now let's actually search for glGetString here. And eventually you'll see that there's something called glad_glGetString. So all this header file is doing is declaring and saying, hey, this function is available. The actual implementation of this glGetString function, well, that's on your driver or your operating system somewhere, okay? So we need to include this file into our program, as well as, well, let's go ahead and see what was in the source directory here. And let's just go ahead and open this up in Vim as well. And if we go ahead and make this a little bit bigger here, let's just go ahead and scroll down for a bit, scroll for a bit. We can actually see some of these settings that were set up, some declarations of variables so that they're in memory. And again, all these objects essentially just being set to null so that they exist somewhere here. Let's actually see if we can find glGetString anywhere. Looks like we can. And again, we could probably search for this forever, but again, it exists there. All right, so let's modify our compilation line. I'm going to keep this structure here just so we can see what's going on here to see if we can get glad up and running here. Now this is where it takes a little bit of practice if you're new to C++ to understand everything that's going on. So again, here's sort of our hierarchy here. And right now we're just compiling the main CPP program, but we also need to compile in the source directory glad.c. And then we also need to include, that's capital I here, our include directory, and I'm just going to include that here. And then in our source file, our C++ source file, we will include glad.h. Okay, so again, glad, or rather, since we are saying here in our include path to look for header files somewhere in this folder here, so I'll double click on it. And then within that folder, I'll look at glad, which is here, and then I'll find the glad.h file, which is here. Okay, so that is what's going on here. Now I'm going to go ahead and compile this. Let's see if it works. And it looks like it is essentially working. I just misspelled SDL GL shading language here at line 18. So let's go ahead and fix that one, because it's actually GL shading language version. Okay, let me show you on the full screen just so you can see that's what it is. All right, and now let's try to compile. And it should compile. Now, this glad library does have one more setup step. And we're going to do this in our initialization like we were previously doing when we were setting up SDL. So if you're using the glue library or something else, this has a similar step here. And it's going to be a little bit of a weird step, but let's go to our initialize program here. And I'm going to go ahead and set up here, initialize the glad library. And I'll do this in a similar way. I'm going to say if not, and there's a glad load GL loader function, and this SDL GL get proc address function. Okay, and we're going to take a little bit of a look at these, but if it doesn't work, we want to exit. And I'll do a cout here. Glad was not, initialized, something like that, and we can fix up the output later if we want. But let's go ahead and look at the SDL documentation here for that SDL get proc address function, just so we can understand again what's going on. So let's go ahead and search SDL get proc address. Let's see, proc. Let's see if we get proc address here. There we are. All right, and let's go ahead and just look at this function here. And basically it gets an OpenGL function by name, okay? So basically what this is, or basically what we're doing with our glad library is just loading up a bunch of function pointers. Now, if you don't know what function pointers are, we just saw some in the glad header file, essentially. So it's enough to just understand for now that this is just loading up all of the OpenGL functions and retrieving their addresses, okay? So that's what's going on with the GL, or the glad load GL loader function here, okay? We could actually do this manually, as it's saying here, and sort of work with it ourselves, but it's a little bit nicer to just use the glad library, okay? All right, now some things that you could do as well just to make your life easier is to move the glad source file out here or rearrange your project. Again, I'll leave that up to you, but you've seen a version that works here. All right, now let's go ahead and just compile this one more time and run our program. And well, it compiled this time and we've got our window. Now let's just go ahead and once everything's set up, let's call our function for get OpenGL version info, and we'll see if our first OpenGL commands are working. So I'll recompile this, I'll rerun it, and immediately we see some information here from our glGetString function. So you can see what video card I have here, the version of OpenGL that we've set up in our shading language. So it looks like it's working just fine. So again, congratulations if you've made it to this step. Your first OpenGL functions, glGetString, If they're working, that means your OpenGL is configured. Hopefully in this series, you're seeing a version greater than 3.3 for the version information here. So 4.1 is great, 4.6 is even better, but at least 3.3, you'll be in pretty good shape. If it's at least 2.1, you'll be able to follow along with this series and get some value. Okay, now before we wrap up the lesson, let's go ahead and do a quick code review because we have written a lot of code here. And of course, you can always go back here, but let's start from the beginning, our entry point. So we wrote an initialize program function that basically sets up our SDL window and OpenGL. So if we go back here to our initialize program, and I'll walk through this slowly, we initialized SDL, set up some attributes for the OpenGL version context that we want to set up, created our window, created our OpenGL context, and then we set up using the glad library a way to have all of those OpenGL functions available to us. And then after that, we looked at our main loop here. And in our main loop, we are handling input. And right now, that's just one event. We're going to implement pre-draw and draw once we get into OpenGL stuff, and then we're able to update the window every single frame. Right now, it's just a black window. All right, folks, so with that said, I think that's a pretty good place to stop, and that's a good code review. I know this has been a pretty in-depth lesson, but really at this point, you're ready to go do whatever OpenGL programming you want. If you're following along in a book, if you're going to make sure that you like and subscribe and follow along with the rest of the lessons, here then you'll be able to program in OpenGL because we've already proved that we have one OpenGL command that works. So any of the other ones in the core profile should work now. All right, folks, so with that said, I'm going to go ahead and close this lesson. We'll go ahead and see you in the next one. Thanks for your time, and I hope you're enjoying learning this stuff in depth and how it works, and we'll see you soon.